All right. I was getting ready to leave. It's 2:46 in the afternoon. I've been here a while. Yeah, it's the life of a professor. I get to contemplate going home at 2:40. But then I was looking at your homework problems, and I was going to do this problem in class. This isn't what you have in your homework, but you've got something similar. So this is going to be in two parts. This is part one, where we're going to do this problem where I've given you with no friction. Okay, and well, we do know the force right here is going to be 8g, and we want to find, again, what are we looking for? The acceleration and the tension in the rope. Okay, so there's a tension. This guy's pulling this way, and due to Newton's third law, this 5 kilogram block is pulling tension this way. It's the same thing as the Atwood's machine, or where we had the blocks being pulled in a straight line. It's no different. I don't think I did the Atwood's machine with you, but it's the same. It's the same type of thing. Okay, and so let's just do this real quick. All right. So what we do is, so what do we have? We've got two unknowns. We need to find t, and we've got to find the acceleration. No biggie. It really isn't. All right. So what's the recipe for it? Well, we've got two equations. And well, one thing we can do, you can change the problem. You can reorient the problem and just say, well, it's the same thing as this. As if this was on a table and this was being pulled by this 8, and this whole thing was being pulled with a force, that would be mg, which is 8 times g, right? Or this is block 2, m2, and this is m1. Okay, so this would be m2g would be the force, and then you've got the tension here and the tension here. And we've worked that problem before. We want to find the overall acceleration because both blocks are accelerating the same. Again, both blocks have the magnitude of the same acceleration the same here. This one's just going in the y direction, and this acceleration is going in the positive x direction. And this one's going in the negative y direction. You can do it either way. And these are the two tensions. Okay? All right, so let's just solve it this way. Let's solve this one this way, just so we get it out of the way, more or less. Basically, we've turned this into, and then I'll do a. So there's going to be three parts of this. I'm going to do this, then I'm going to do an Atwood's machine, then I'm going to show you the other, the one that's a lot like a more difficult problem in your homework. All right. So this one's pretty straightforward. So we've got we want to find the two tensions. All right, well, first, let's just look at the entire thing. Since we've changed the sum of the forces in the x direction, and this is 5 kilograms, is equal to 5 plus 8, because we're looking at the acceleration of the entire thing, okay, times sum A is equal to m2 times g, because we've taken this picture and put it here, so that's going to be the force here. So this is just equal to, so we have 13, because the tensions go away, because put in plus t minus t, so the two tensions went away. And so we wind up with, we've got 13 times A is equal to 8 times G. So A is equal to 8 over 13 times G, whatever that comes out to be. And then so we know the acceleration, so we can just look at one block. So just look at one block, and let's just take the 5 kilogram block just for giggles, because it's got an acceleration we know is 8 over 13 times g. G again being gravity, 9.8 meters per second squared. Okay, but now it's going this way. That's why we don't put we're just taking the magnitude of it. That's the acceleration. That's equal to A. And then, and this is a 5 kilogram block, and the only force working on it is T, so what's the tension? Some of the forces in the x direction are equal to 5 times 8 over 13 times 8 over 13, which is equal to T. There's your tension. It's done. All right, so that wasn't too hard. Now, let's put this thing and let's add a frictional force here. And it should be okay.